Today we will be looking at oral and parenteral dosages. These examples are on page 27 of your workbook. Oral and parenteral dosages, the problems are worked alike even though they're different ways you administer a drug. Oral drug would be like a cough drop that you administer orally. Parenteral is when you give something in a shot. But as far as the mathematics, how we compute the dosage is the same. Oral and parenteral dosages, you will have a bottle of a liquid that's labeled either in, per, or contains. Then we work these like the in per contains problem that we actually worked on the first test. Whatever it says in per contains, we write it down, we match labels, and do a cross product. So on page 27, number 1. Number 1 says 5 milligrams in 5 milliliters. So we write down whatever is in per contains, but we write it down as a proportion, and we keep the labels. 5 milligrams in 5 milliliters. The reason you have to keep the label is now I say 8 milligrams are ordered, we know to put the 8 across from the milligrams. If you don't keep your labels, half the time you're going to get these upside down. So whatever's in per contains, you write it down, you simply match labels with what is ordered. So here, 5x is 40. When I divide by 5, x is 8. And we look up here and look across to see what our label is. So our answer is 5 milliliters. Now, this one was pretty obvious. You might have just could tell if there's 5 milligrams in 5 milliliters, and there's going to be 8 milligrams in 8 milliliters. But if we set them up all the time just like this, then we'll always know how to work these. Number 2 says potassium chloride 10%. I'm going to change the problem a little bit. The problem says grain 6. I'm just going to mark that out and pretend the problem said 20 milligrams. Again, we're trying to get away from working with the grains whenever possible. We're going to work problems with milligrams. So this would be more like you would see on a test. 10%, 20 milligrams. Now, this is the only time they don't give you a label. Everything else has to be labeled. Percent, you just have to know, is always grams over milliliters. You have to know this, and you have to put the label on it. Percent is always grams over milliliters. So 10% is 10 over 100. That's what the percent means. Percent means 10 over 100. We have to label it grams over milliliters. Write the label on it, or you're going to miss this problem every time. Percent has to be grams over milliliters, so I can't put 20 milligrams here. 20 milligrams I have to convert to grams, and what is that when I change it to grams? 0.02. You have to go 1, 2, and 1 more, so it's 0.02 grams. Now, if you didn't label it grams over milliliters, you're going to put the 20 in here. You cannot put 20 milligrams in here. You have to write 0.02 grams. Oh, I didn't. I'm just changing this problem altogether. I said just mark that out. I'm not even doing that problem. I'm doing a different problem. because we're not going to work problems with grains, so I wanted to see one like this. So 10x, when I multiply by 100, 10x is 2, divide by 10, and what does this label need to be? If you always write your label down, then you make sure you match, and you also know how to label your answer. I'm sorry? I can't hear you. Never, never put metric system in a fraction. The question was, should she work this as a fraction? Don't ever give me a metric system as a fraction. Metric system is always a decimal. So the answer here has to be a decimal. Okay, number 3 says 20 milligrams per 5 milliliters. But what's been ordered is 1/3 of a grain. So I'm going to have to do a conversion. What is the conversion from grain to milligrams? And I know to go to milligrams because that's what I want up here in the problem. So the conversion for grains to milligrams is 1 grain is 60 milligrams. So if I use 1/3 of a grain, I'm just going to go off and do my conversion problem before I do the medicine. So X is 1/3 times 60, and that now is milligrams. We have to do the conversion problem, then we turn around and do the problem. But if I wanted to give 20 milligrams, and there are 20 milligrams in 5 milliliters, how much would I give? You'd give the 5 mils. So this was really more of a conversion problem, because as soon as I convert it to 20 milligrams, I can see I needed to give 5 mils. That one okay? Number 4 gives us a 200 milligrams in 5 milliliters. But this one says 50 milligrams per kilogram per day. This is one of these per problems, 50 milligrams per kilogram per day. I'm not even going to look at the dosage yet. When I see this type of problems, I go through my 3 steps first. First, take the pounds divided by 2.2. That changes the person's weight to kilograms. We have to have kilograms, so we always divide pounds divided by 2.2 to get kilograms. Then we multiply the kilograms times the dosage. But this was per day. Can't read that, that's per day. So the third step is to take that and divide it by how many doses we're given in a day. And this says it's given every 4 hours. If it's given every 4 hours, how many times a day do I give it? 6 times. Okay. Here again, it doesn't matter if you keep 1 decimal or round it off to 417. You're going to get close enough to the same answer in the end. But these 3 steps are every time we see the per. Divide by 2.2, multiply times the dose, divide by the number of times. It's always divide, multiply, divide. Now it says this is my dose. So I go pick up the bottle and it says 200 milligrams in 5 milliliters. The N per the contains, and I want to give 416.7 milligrams. Always watch that your labels match. This was milligrams, and this is milligrams. So 200x is 5 times 416.7. And then divide that by 200. Milliliters, we're always going to give to the nearest tenth. So milliliters will always round to the tenth. Most hypodermics are measured in tenths. Most things, if you're going to give something orally, tenths is as far as it can be broken down. So milliliters, always round it to the nearest tenth. Number 5. We have 0.0025 grams per milliliter. I'm supposed to give 1.5 milligrams. Here we have to notice that we have to do a conversion. You cannot put milligrams in the same problem with grams. It does not matter which way you go. Normally, it's just always best to go to milligrams. Milligrams are just easier to work with. So if I decided to change this one, it would be 2.5 milligrams per milliliter. And per milliliter means 1 milliliter. I moved the grams to make it milligrams. So if I have 2.5 milligrams per milliliter, and I'm ordered to give 1.5 milligrams. The labels always have to match. It's why I keep those labels. If you don't keep those labels, you're just going to stick any number there. The labels have to match. 2.5x is equal to 1.5. 0.6 and x is milliliters. Number 6, the physician orders 0.015 gram. That capital H simply means as a hypodermic, so it just is telling you to give it as a shot. But as far as the math concerned, that H doesn't have anything to do with the problem. But that's all H does, is means you're going to give it in a hypodermic. Or give it as a shot. The dose on hand is 0.06 grams in 1 milliliter. 0.06 gram in 1 and I'm ordered to give 0.15. .06x is 0.15. Now, because these are in milliliters, they're metric, we always just do this on your calculator. Just let your calculator do all of these oral and parental problems. Now, my answer is 0.025. If we're going to round it to the nearest tenth, whoops, mils. We always put milliliters to the nearest tenth. If it's 5 or more, we round up to go to the nearest tenth, and that is ml there.
You don't want to take it to milligrams?
We can't change milliliters to milligrams. Milliliters is wet, milligrams is dry.
Well, I mean, like the grams, like 0.05 grams.
Oh, I don't change them if they're already the same. That way I'd have to change two things. As long as they're the same, I just keep them whatever they are. It wouldn't hurt to work with milligrams, but we don't have to change two things. The question is why I didn't change it to milligrams. As long as they are alike, I don't have to do a conversion. The physician orders 1/4 of a grain. A bottle is labeled 0.006 grams in 1 milliliters. But the order is in grains, so I'm going to convert grains to grams. What's the conversion for grains to gram? 15 grains is 1 gram. And we have 1/4 of a grain. So 15x is 1/4. Now, the easiest way is to do this on your calculator. Because we are going to the metric system, it can be done on the calculator, and first just take 1 divided by 4. Because we are going to the metric system, we want it to be a decimal, and now 0.25 divided by 15. Now this one we can't go to the nearest tenth because that would be too small. So here I'm going to keep 2 numbers, not counting zeros. And what is that number now labeled? I was converting it to grams. So now if I have 0.006 grams, 0.017 grams, 0.006 gram, X. Okay, I took the 0.25 and divided it by 15, just to solve for X. And here I've got 2.8 milliliters. Now, this problem could have also been worked another method. Anytime you have a very small amount, it's okay to change it to milligrams. If you move this over to milligrams, you would have 6 milligrams. If you change it to milligrams, then you want to change your 1/4 of a grain to milligram. 1 grain is 60 milligrams. So 1/4 of a grain is X. 1/4 times 60 is 15 milligrams. This is the same problem number 7, except in working with 0.006. When it's that small, I can move it over and work with milligrams. And now 6 milligrams in 1 milliliter, 15 milligrams is X. I don't get exactly the same answer here.
So we get 2.5, we get it wrong?
No, I will take either answer if you show me your work. But if I have one answer and you have the other and I don't see any work, I'll count it wrong because I won't know how you got it. As long as you show your work, I will take either answer on this problem. And a lot of times it is just easier to always go to milligrams. And again, I will take either answer if I see your work, so I see why yours is different. It's still a legitimate problem. Number 8, the physician orders 300,000 units. Penicillin is often in units instead of grams or milligrams. The dose on hand is 3 million units in 10 milliliters. Now, they used to allow you to abbreviate units as a U. You cannot do that. So you must keep the whole word units. And we have been ordered to give 300,000 units. Here it's just making sure you keep up with the right number of zeros. And I don't require you keep commas, but sometimes commas help you keep up with the right number of zeros. 3 million times X. But then if I multiply 300,000 times 10, I'm going to get 3 million. The 300,000 times 10 puts one more zero on the end. So if I divide by 3 million, I get 1 milliliter. Number 9 says we have a 1 to 2,000 solution. Now, anytime it is not labeled, we have to label it grams over milliliters. Now, the ratios we said could be anything if you label it. It could be 1,000 milligrams to 2,000 milliliters if you label it. But if it's not labeled, just like the percent, it has to be grams over milliliters. So the 1 to 2,000, I have to label grams over milliliters. If they don't write a label on the ratio, then it has to be grams over milliliters. And 0.25 milligrams. Well, I can't put milligrams here if I have grams here, so it's 0.00025 grams over X. That's the reason I had to know to label this gram so that I knew that I could not put a milligram here. So X equals 2,000 times point. If you don't change the label to grams over milliliters, you're going to get a ridiculous answer like 5,000 milliliters. Picture a shot of 5,000 milliliters. That's a quart. So if you get an answer that you know is ridiculous, go back and check grams and milliliters.
Could you do milligrams?
You could change this one to milligrams then too. As long as you start it off like this, then you can change it. I don't know why we went from number 9 to number 20, but I guess we'll do number 20 next. 25 milligrams per milliliter. Prepare 3/4 of a grain. The most common conversion we're going to use is 1 grain is 60 milligrams. I'm asked to give 3/4 of a grain, so I have to convert it to milligrams. X 3/4 times 60. Now you can do the arithmetic as the fraction, or because we're always going to the metric system, you could go ahead and take 3 divided by 4 and then multiply that times the 60. Whichever way you want to do it, but the final answer has to be a decimal if it doesn't come out equally.
You need to move your paper up.
There we go. You can multiply 3/4 times 60 and you'll get the same thing as 0.75 times 60. But I just took 3 divided by 4 so I can work with my calculator. So now the original problem said 25 milligrams in 1 milliliter. I'm supposed to give 45 milligrams. 25x is 45. .8 mils. The biggest deal on these is the conversions. You're going to have to know all the conversions, but the main one we'll use is 1 grain is 60 milligrams. We have to do a conversion to make sure the labels are the same. That's the reason, keep up with these labels. If you don't, you're just going to stick any number you want to up here. Keep up with the labels so you make sure the labels match.
We have a question.
Uh-huh.
I was just gonna ask, do we have, like I know 3/4 of a grain is 45. Do I have to work it out?
No, If you can just see that, you can just write down the answer.
Okay.
Any questions on this? The quiz next time is going to have a tablet problem. Then it's going to have the oral inferential problems. And remember your percent or ratio, you have to label grams over milliliters. That's probably going to be the most missed one is the percent. You're not going to put a label, and you're going to put milligrams in there and get a really terrible looking answer, like 2,000 milliliters. The homework is page 28 through 31, but I want to omit problems 8, 13, and 24. Some of them are because they were in the apothecary system and were just not going to work in the apothecary system, and some of them were just because I plain typed in the problem wrong. So omit those 3 problems, pages 28 through 31, and we will have a quiz on O and P next time. The next test is 1 week from tonight. We will have a quiz on Wednesday on O and P. Yes. Well, except there's 1 tablet problem on the test. Quiz Wednesday. Okay? Okay. We'll see you next time.
It's on the 28th.
Okay, let me turn off the tape. Okay. Solutions. Solution problems are in your book on page 39. The problems we're going to be working are on page 39 in your workbook. Okay. Today we're going to look at solutions. Solution problems are in your book on page 39. The problems we're going to be working are on page 39 in your workbook. Now, okay. Today we're going to look at solutions. Solution problems are in your book on page 39. The problems we're going to be working are on page 39 in your workbook. Now, solutions, we actually worked solution problems on the first test, and to make a solution, we have to remember the formula strength desired divided by strength